Hey class, welcome back. Here is another example problem dealing with impulse and momentum that I had for you guys. So we have here my beautiful artwork. We have a dump truck here, and it's sitting on some weighing platform, a road scale type of deal, and it's going to be loaded with sand. All right, and so what's going to happen is sand is going to come pouring out of here, all right, shooting out, and it's going to come down and hit the truck. It'll slowly pile up, right? You'll get this pile of sand as it continues to fall. But the fact that sand is impacting the truck will result in the scale reading above the true weight of the truck. And not just talking about the weight of the sand, but really weighing down and adding to the overall weight it records above, oh boy, howdy, excuse me, above the true weight of what's sitting on it as a result of the force of the sand impacting the truck. Because of that impulse, you're going to get an above average reading. And think about it this way, if that's kind of confusing to you, or not average, above true value reading. Think about like if you were to jump on a bathroom scale. The moment you jumped on and landed on the scale would initially read much higher than your true weight. Not because you magically gained weight by jumping, but because the impulse of the ground pushing up to stop you is actually causing the force to appear larger than it really is. So that's what we're trying to find out, is what is that difference? What is that additional force? And so as I was just saying, the force above the true reading is really just going to be a result of the impulse. So if we think about impulse momentum theorem, right, if we recall, impulse is equal to either your change in momentum or it's equal to the average force multiplied by the change in time. Okay, and so in this case, everything's in the y direction. So in the x direction, we got nothing. And so we're only looking at the y direction. So impulse in the y is going to be equal to the change in the momentum in the y direction, which is going to be equal to the force in the y times the change in time, which is what we're trying to figure out. Okay, so it's this force that we want here. All right, so our change in momentum, well, that's going to be the mass, the total mass of our system, right? Or no, correction, not the mass of the system. This is going to be the mass impacting the top of the truck. So that's the mass of the sand. Maybe I'll put a subscript S. Mass of the sand times V final of the sand minus mass of the sand times V initial of the sand, right? And that's going to be equal to the force in the y direction times the change in time. Cool. Sounds good. Let's see. Well, we know the sand is going to come to rest because it's hitting the truck. So this is going to be 0. So we're left with minus negative mass of the sand times V initial equals the force in the y times delta t. Problem is, we don't really know V initial, the mass of the sand, or time. Because what is this time? This is the time that it's impacting the truck, right? Which we don't even really know. We don't really know the amount of sand that's impacting or the exact time for which the impact occurs. But what we do know is that there's a certain mass flow rate, that there's a certain mass exiting here, and that mass flow rate, which mass flow rate is mass over time, the mass flow rate is 45.4 kilograms per second. So if we divide both sides by delta t here, we get force equals negative mass over delta t times V initial. So we have here in our equation the mass flow rate. So the impulse that is experienced is directly dependent upon the mass flow rate. So if we can figure out the initial velocity, then we can get the mass flow rate. So what is this initial velocity? A lot of people want to say, oh, that's the velocity that it's coming out. It's probably 0. No, this is the initial velocity for the impact, right? Impulse momentum theorem up here, this is just applying to the impact that's occurring. So what we're looking at is the initial velocity just before it impacts the bed of the truck versus the velocity after the impact is finished, which we know is final. So we're looking at the velocity right here just before it hits the truck. And since we know that this distance h is how far it's fallen, we can calculate its velocity using either kinematics or using conservation of energy. Up here at the top, if we do conservation of energy, so again, if we're thinking about from point 1 maybe to point 2, from 1 to 2 we're using conservation of energy. What that means is kinetic energy at 1 plus potential energy at 1 plus work done by non-conservative forces equals the kinetic energy at point 2 just before it impacts plus the potential energy at point 2. It starts from rest, so this is 0. There's no outside work, that's 0. And just before it impacts, it's now at the bottom, so that's 0. So what we have is mgh is equal to 1/2 mv squared, where this v here is the v at point 2, which is our v initial that we're trying to find. So I'll just call that v initial. The mass cancels, which is good since we don't really know, and the v initial is just the square root of 2gh, which we can plug in over here. Now we're doing the square root. Which direction is this? It's moving down, right? So I call that a negative velocity. So if we pop over to our other equation, we're going to have force in the y is equal to negative mass flow rate multiplied by negative square root of 2gh. So our force in the y is going to be equal to negative 45.4 kilograms per second multiplied by negative square root of 2 times 9.8 meters per second multiplied by our height of 1.94 meters. And so we scroll up to make some space. If we do the math, our negatives cancel out, and we should find that the sand impacting the truck causes the scale to read an additional 280 newtons. Boom, box worthy. So again, the scale is reading more because it's slowing down the sand. The moment that the sand stops flowing, the moment it stops impacting, the scale will be accurate. But as a result of the truck slowing down the sand, causing it to stop its downward movement, there's an impulse, there's a force, and we just calculated what that force is. Hope that makes sense. Let me know if you have any questions.